Hello, it's me again. We will be solving Big Circle 3 this time. Please print from EDSB the material and follow along with me one more time. Thank you. But before we proceed, it is better that we review one more time the three important theorems that are so useful in solving this kind of problems. The inscribed angle theorem, which states that the measure of an inscribed angle is equal to half the intercepted arc. Hence, measurement of angle 1 is equal to 1/2 x degrees. Half the sum theorem states that if an angle is formed inside the circle, then it intercepts two arcs, x degrees and y degrees arc, and measurement of angle 1 is half the sum of the intercepted arc, hence half the sum theorem. And finally, half the difference theorem, which states that if an angle is formed outside the circle, then it intercepts the circle in two arcs, x degrees, the big one, and y degrees, the smaller one, and measurement of angle 1 is 1/2 x degrees minus y degrees. Now we are ready to solve the problem. Let us include all the information provided in the problem, okay? In circle A, angle HCE is 120 degrees. Angle HBC is equal to 40.5 degrees. That's the whole angle. Measurement of angle GHC is 140 degrees. Another big angle here, okay? Measurement of arc LH is equal to 25 degrees. Let's change color. 25 degrees. And the measurement of arc EF is 70 degrees. Those are the information provided to us. Let us make use of the information provided to us. This is arc EF and given to be 70 degrees. And this other arc is arc LH and 25 degrees. And therefore, I can take the difference to make the measurement, to find the measurement of this particular arc, okay? Since the angle is outside the circle, then that's half the difference theorem. 70 minus 25 is 45 degrees. Half of 45 degrees is equal to 22.5. So that is 22.5 degrees. The leftover angle, this angle here, is 40.5 degrees minus 22.5 degrees is equal to 18 degrees. So that is 18 degrees. Before we continue, let us recall this very important and useful theorem. This angle, x degrees, intercepts this particular arc. And by the inscribed angle theorem, it measures 2x degrees. Okay? And this particular angle, which is y degrees rather, intercepts this particular arc, and the measurement of this blue arc is equal to 2y degrees. 2y degrees. However, 2x degrees plus 2y degrees is equal to 360 degrees. Add up to one full circle. Divide everything by 2. X degrees plus y degrees is equal to 180 degrees. Thus, we have the following theorem, which is very useful. The opposite angles in a quadrilateral that is inscribed in a circle add up to 180 degrees. Okay? We'll use that in solving the problem. This quadrilateral is inscribed in the given circle, and therefore we'll just use the theorem we just recalled, and that is 120 degrees. The supplement of 120 degrees is 60 degrees. That makes the opposite angle, which is angle HGE, 60 degrees. Furthermore, this is 140 degrees. The supplement of 140 degrees is 40 degrees. So this other angle is 40 degrees. However, this is also a quadrilateral that is inscribed in the given circle. Thus, this angle F is 60 degrees because it is opposite 120 degrees. They are supplementary to each other. Now let us introduce a variable to solve this problem. Let us assume that this particular arc LC, is equal to x degrees. Next, this 120 degree angle intercepts this big arc here, and that big arc here will become 240 degrees, right? So let us write that to be 240 degrees. This one is 240 degrees. Thus, the remaining angle, this remaining angle, arc CE, is equal to 360 degrees minus 240 degrees minus 25 degrees minus x degrees. And we can simplify that to 95 degrees minus x. Next, we will form an equation involving 18 degrees, x degrees, and this particular arc. 18 degrees is formed outside the given circle, so we can have a new equation which is 95 degrees minus x, that's the big arc, minus x degrees. Half the difference divided by 2 is equal to 18 degrees. 95 minus 2x is equal to 36 degrees, or x is equal to 29.5 degrees. So we can now replace this x by 29.5 degrees. 95 minus 29.5 degrees is equal to 65.5 degrees. This angle is 40 degrees, and it intercepts this big arc here, arc GC. Therefore, arc GC is 80 degrees. So 80 degrees minus 25 degrees minus 29.5 degrees is equal to 25.5 degrees. That makes arc HG equal to 25.5 degrees. The remaining arc, arc GF, is easily determined because the full circle is 360 degrees minus this arc, minus this arc, minus this arc, and the last arc, which is 70 degrees. So 360 degrees minus 25.5 degrees minus 25 degrees minus 29.5 degrees minus 65.5 degrees minus 70 degrees is equal to 144.5 degrees. So now I will mark this arc GF, as 144.5 degrees. Let us first answer as many questions as possible because we have labeled so many things in our diagram. So, measurement of CEG is 40 degrees. Measurement of LEG is, it is an intercepted arc, and therefore it is equal to 25 plus 25.5 divided by 2 is equal to 50.5 over 2, which is equal to 25.25. Arc FG is this particular arc, and therefore that's 144.5 degrees. Measurement of angle EBF is 22.5, okay? So that is 22.5. While HG is 25.5. So that is 25.5 degrees. And then measurement of angle ECD, this is ECD, is 65.5 degrees. 65.5 degrees. Measurement of angle HKG, this angle is inside the circle, therefore we are going to use half the sum of this arc and this arc. So 70 degrees plus 25.5 degrees is equal to 95.5 degrees. Divide this by 2 is equal to 47.75 degrees. So this is 47.75 degrees. Measurement of angle LMC. This is inside the circle. Therefore, we are again going to use half the sum of this arc and this particular big arc here. Okay? So that is 70 degrees plus 144.5 degrees plus 25.5 degrees is equal to 240 degrees. And 240 degrees plus 29.5 degrees is equal to 269.5 degrees. Let's take half of it. 269.5 degrees divided by 2 is equal to 134.75 degrees. So this angle is 134.75 degrees. And then this one is 134.75 degrees. Finally, we have the easiest question because we solved it at the very beginning. This is 18 degrees, okay? So, that means the measurement of DBE is 18 degrees. That's all, and thank you very much. See you next time.